So let's talk about layout, because you don't always get a piece of paper that has a starting point for your multi-view drawing. Sometimes you have to do calculations on your own, and it's not that difficult to do. It's a little bit of addition and subtraction, really, to lay things out properly so we don't get an embarrassing mistake where our views are squished together or stuffed in a corner or so big they're falling off the paper. So what we have to do is we have to establish what we're looking at right now. Right now, this is the edge of the paper. This outside rectangle you're looking at would be the edge of our piece of paper. The next line in is going to be the border. So we know there's a heavy border that goes all the way around the piece of paper, 4 sides. At the bottom of the paper, we have a strip, we call it the title block, and written information generally goes in there. So the area we have to work within is actually this area here. It's actually this area. Everything outside of there is either the border or where we're going to have written information. We can't have our drawing out there. So first step is let's figure out how big our piece of paper is. And once we do that, how much space do our views require? And then how much space do we have to work with? And then we can calculate where to start the drawing. So step 1, what is the size of the piece of paper? Well, typically we're going to have smaller drawings in the hand drawing section of this class. Drawings are 8.5 by 11, so we have 11 in width and 8.5 in height. Okay, so that's the overall size of the paper, 11 by 8.5. Now that's not the size of the drawing area, right? Because we have to knock off on the width a 1/2 inch here and a 1/2 inch here. So our space that we have to work with inside the border is actually smaller. Our space inside the border is actually 10, and our height inside the border area in the y direction is not 8.5, it's 8.5 minus a 1/2 and a 1/2, and usually on our drawings 3/8 more. So when we do the math and we take that off, we're talking about 7 3/8. So our drawing space, our drawing canvas in between the border and the title block is 10 by 7 3/8. That's how much space we have to work in. Now we need to figure out how big are these drawing elements that we're going to be adding. So let's just pull some numbers out of the sky. Why not? Let's say our front view is 4 inches wide. And let's say our side view is 2 inches deep. And let's say that we want 1 1/2 inches in between the two views. This is our first set of numbers we're going to work with. So let's do a little bit of math. I have 10 inches to draw in, but I need to take away the sum of those 3 widths. So I have 4 inches and 2 inches and 1 1/2 inches. See, my views and the space between the views is actually 7 1/2 inches. So when we look at that and do a little bit of math, we figure out that we are left over when we're done with 2 1/2 inches of extra. See, if I took the corner of the triangle here and stuck it down there in the bottom left corner, and I went 4, 1 1/2, and 2, well, the leftover at the very end here would be that 2 1/2. Now, 2 1/2 is the total leftover. I need half of the leftover here and half of the leftover here, which means we take this number and we cut it in half. And that gives us a total of 1 1/4. So what did we just figure out? Well, we just figured out that if we come over from the border 1 1/4, and then we go 4 inches and 1 1/2 inches and 2 inches, we'll have 1 1/4 over here at the end, so that the front and side view are centered on the paper. Okay, so look, nothing tricky. A little bit of subtraction, a little bit of division. It's not that tough. And now we know exactly how far over to come from the border to start the front view. Let's do the same thing for the y direction. Okay, let's say the height of the front view is 2 inches. Okay, it's also the height of the side view, right? And then I want to add a 1.5 inch space between the views, just like I have here. And then the depth, well, that's 2 inches also. Okay, now how much do we start off with? See, we started off with 7 3/8 of an inch, right? So we started off with 7 3/8. How much are we taking away? Well, we're taking away 2 and 1.5 and 2 more, right? Because that would be the total height. 2, 1.5, and 2 more. So we're taking away 5.5 inches. What do we get for a result here? Well, we subtract, we see that we get an answer of 1 7/8 of an inch. So that means if I took my front view and stuck it in the bottom corner, and then 2 inches up, I left a gap, and then we put the top view on top of that. When I was left over, I'd have a big space up here, 1 7/8. Well, I don't want the corner down here on the title block, do I? So I want to have some space here and here. So I'll take that 1 7/8 and I'll do my little trick. We'll cut it in half. Half of 1 7/8 is 15/16. What does that mean? Well, it means that if I come up from the bottom 15/16, and then I go up my 2 inches for the front, and my 1.5 inches for the gap, and my 2 inches for the height, when I'm all done, I will also have the same amount, 15/16 up here, between the top of the border and the back of the top view. Okay, and that is the goal. We're trying to center things on the paper. We're trying to find out where that sweet spot is, right, for our corner to start the drawing. And all it requires is a little bit of arithmetic to do that. Now, when it was time to add some of this stuff up, if it's been a while since you've been in a math class, you might want to tune in. Otherwise, you can skip over this next part. We're just going to talk about adding and subtracting fractions from one another. The 2 little bits of arithmetic I did here involve subtracting 7.5 from 10. Well, I mean, this is easy, right? Usually taking away a whole number from a whole number is fine, or even a whole number and a fraction from a whole number is not a problem. Especially when we're working with halves and quarters. But if you're working with goofy numbers, just remember that you can't take away something from nothing. So really what we're doing is we're taking one of those, right, a single unit, and we're making 2 halves. And we're taking 2 minus 1 is 1, and then 9 minus 7 is 2, right? And that's how we're able to do that. If you can do it in your head, great. If you can't do it in your head, no worries, just do it on paper. For my other little bit of arithmetic there, 7 3/8 minus 5.5. Well, you know, anytime you're working with addition or subtraction of fractions, it would be easiest to convert them to like denominators. So what does that mean? Well, it means we need to get everything in eighths, right? 1/2, how many eighths is that? Well, what do you multiply 2 by to get 8? You multiply by 4, right? So you could call this 4 times 2 is 8, 4 times 1 is 4, 5 4/8, right? It's the same thing as 5 1/2. This is an improper fraction though. We don't say 5 4/8, we reduce it until we get down to the 1/2. But you see what this lets you do is it lets you work with the fraction here and the fraction here and do your subtraction or your addition, right? So if we were adding, it'd be easy. It'd be 3 and 4 is 7, and the denominator is 8, 7/8. But we're subtracting. So what are we going to do in this case? Well, can you take 4 away from 3? Not with fractions. So what do you need to do? Well, we need to make this number bigger than 4. And the way we can do that is we can steal one of the units from the 7. So I'm going to take that 7, I'm going to break it into 8/8, because we're working in eighths, and I'm going to add 8 more eighths to this. So that becomes 11/8. It is 6 and 11/8 is the same as 7 and 3/8. Okay, and then my math becomes so much easier because I can take 4 away from 7, and 5 from 6 gives me the 1. Okay, so the secret to adding and subtracting, unlike fractions, is make them a common denominator, steal from the whole number, and add a numerator that matches the denominator to whatever numerator you already have. And then you'll be able to do your math and come up with your answer. When it's time to cut fractions in half, I do it like this in my head. If I want to cut 2.5 in half, well, we all can do this one. What's half of 2? 1. And what's half of a half? 1/4. Okay, and then we put it all back together. Half of 2.5 is 1.25. Now, you might know that. You might know that half of a half is 1/4, but if you don't, let me show you how to do it. Right, basically, we're looking at this. 1/2 divided by 2. And the easiest way to do these cut your fraction in half questions is just multiply the bottom times 2. Not the top. Keep the top whatever it is. Multiply the bottom times 2. 1/2 of a half is 1/4. If we did it again, 1/2 of a quarter is an eighth. 1/2 of an eighth is a 16th. And so on, and so on. Okay, easiest way, double the bottom number. That creates your fraction cut in half. So how did I cut this guy in half? 1 7/8. Well, I broke it into 2 pieces. 1 broken into 2 pieces is a half, right? And 7/8 broken into 2 equal pieces. I just doubled the bottom number. It is 7/16. Okay, now in my brain I can add these, but let's just talk about the process if it just doesn't pop into your head and you're not used to working with numbers like these. You really can't add 16ths to halves, can you? Because they have different denominators. So the easiest thing to do is convert this into 16ths. What do we multiply 2 times to get 16? Well, it's 8. So 8 times 1 is 8. 8 times 2 is 16. 8/16 is 1/2. Okay. And then when it's time to add them back together, we have 8/16 and 7/16. Well, 8 plus 7 is 15. And the denominator just comes right across, 15/16. So this little mini math lesson, hopefully this is helpful. If it's been a while since you've had to work with fractions, please don't let the kinds of fractions that we're doing scare you away from doing the work. These are the fractions that we use to bake cookies or to make a batch of pancake mix. It's always a nice even number down the bottom, a 2, a 4, an 8, right? When we get really small, a 16th. But this is not something that is beyond your mathematical ability, even if you don't have a lot of math confidence. All right, so this wraps up the discussion and the hands-on on how to calculate a starting point for a drawing if you're doing your own layout.